Okay, we're picking back up with chapter 6. Today's stuff is a little easier than the stuff we ended with last semester, right? Drawing all those circles. Today's stuff will be a little easier, quicker to run through. Okay, so we're talking about triangle mid-segment. What would a mid-segment be?
Middle.
Yes, the middle of a segment. Okay, so middle of a segment on a triangle, what we're starting with today. So the mid-segment of a triangle, let me change this. Is a segment that contains the midpoint of two sides of a triangle. The midsegment of a triangle is parallel to the third side. I don't have enough room to write here. And it's half as long as that side. Okay, so if this is the midsegment, right, DE is parallel to AB. Right, which is marked by the arrows. We see that there, yes. Okay, and then it's half as long as that side. So DE is equal to half AB. So the shorter side, your midsegment, is always half of the longer side, which that makes solving pretty simple because if we have the longer side, we just take half. If we have the shorter side, then we double. Yes. On the bottom one? Yeah. No, because we're talking about measure. Remember, you only do it when you're saying they're parallel, perpendicular, things like that. When we talk about measure, we won't use it. Okay? So, knowing that, when I look at example 1 and it says solve for the variable, given that this is a midsegment, so we can only use this if we know this is the midsegment. So if it didn't tell us this, we couldn't say it, but it does, right? So if the bottom side is 16, what is x going to be equal to? 8, because it's half the longer side, okay? On problems like that, I don't really expect you to show work, okay? I think we could take half of 16. Now, on the other one, right, we do need to show some work. So how could I set up example 2? Any thoughts?
3x minus 5 equals half of 56.
Good. Yeah, 3x minus 5, the shorter side, has to be half of the longer side, okay? What's half of 56? Somebody said it, I think. 28. So 3x minus 5 is going to be equal to 28. And then I just have 2 steps to solve for my answer. What's my first step? Add 5 to both sides. What's 28 plus 5? So 3x is equal to 33. My last step, divide, so we get x is equal to 11.
Do we need to put like 1/2 and
No, no, you could start. I do not care if you just started straight from 28. I just write it so we kind of get in that habit. Okay? All right. What about example 3? Let's just talk about setting it up first. So what should I start with?
2x minus 3.
Okay, 2x minus 3, and what am I going to set that equal to?
equal to half of 5x minus 5?
I'm just going up here because I have a little more room. Okay, now I know we can't really take half of 5. You can. We'll just change it to a decimal. Okay, so we're going to get 2x minus 3 equals 2.5x minus 6. Okay?
Minus 2x.
Sure. So that would give you negative 3 equals 0.5x minus 6. So we get 3 equals 0.5x. Last step. Divide by 0.5. We get x is equal to 6. Okay? Now, example 4 is a little bit different, correct? From the 3 that we've done already.
Yes.
Does anyone know some things we know about those two sides here?
Which two? They're parallel. No, it isn't like that.
Well, these two sides are parallel. We do know that, but we don't really care about those two sides in this problem. So what do I know? Let me find my little cursor. What do I know about these two sides?
It has X.
True. What is this right here called?
Oh, I mean,
A mid-segment. What does a mid-segment do?
cut it even. So they're equal.
So this point right here is the what? Midpoint, right? Or the halfway of this line. So if this is the midpoint, what do I know about these two segments?
Equal.
They're equal to each other. So how can I solve for x?
3x equals 18.
Yeah, 3x is equal to 18. So x is going to be equal to 6. Okay? Same thing on the other side. What do I know about 20 and y?
They're equal.
They're equal. So y is just equal to 20. Hello. I do. Yep. Tucker. Okay, we okay with those? Ready for the good stuff?
No.
Come on. Let's go.
I think it's gonna get harder.
Yeah, sure. We don't want to keep it too simple.
No, we do.
All right. On the back page, example 5 says, in triangle GHI, J, K, and L are midpoints, and then it tells you the length of IG, GH, and JL. So the first thing we're going to do is go through and label those things, okay? So IG, down here on the bottom, is 30. GH over here, the whole thing is 20. And then JL, sorry, J, it doesn't give you that one. Sorry, it gives you JL. Let me find that. So JL here is 18, this one. Okay. It wants to find the lengths of LI, KL, and HI.
LI is 15
Okay, how do I know that LI is 15?
because GI is 30 and L is the mid-segment.
Good. So L is the midpoint of GI, so that tells us each side is 15. So I do agree with you there. LI, let me find that, 15. Okay, okay.
Oh, wait. No.
So
But
if I'm trying to
HL
find KL here, where can I look?
It's 10.
Yeah, right? I can look down at the bottom. So remember, if this whole line is 20, then KL has to be half of that. So Serenity's right. KL is going to be 10.
Would HI be 30?
Yeah.
Okay, and then HI would be 36. Why? Because JL here is 18. So HI has to be 36. Okay, good. All right, then is it possible for me to find the perimeter of triangle GHI?
Yeah.
What numbers am I adding together?
30, 36, and 20.
So 20
86.
plus 30 plus 36 is equal to
Quick math.
86.
Like 18 plus 15.
Nope. So right here, I know sometimes you guys, I know this is confusing when you have all these different lines drawn in the middle, okay? But if I'm trying to find this length of HI, remember JL is parallel to it, okay? So then if JL is 18, I double it to find the longer side. So same way that we found KL here was 10, right? We had the longer side of 20, so then we take half to find the shorter side. Okay?
For JK, would it be PI?
So would it be possible for us to find JK, you guys?
Yeah,
Yeah. Look to the longer side. What's the longer side?
PI.
30, so JK would be 15. Yeah. Okay? All right. So in example 6, we're just going to go through and we're going to state the parts that are parallel and then the parts that are congruent to each other. So let's do parallel first. So PR is located here. What segment is parallel to PR? NO, right? It's always going to be the side that's double it. So NO. Okay, somebody else tell me if I'm looking at NM, what is parallel to NM? QR. Good. All right, last one. Somebody else, if I'm looking at RO, which RO is the same as OM, agree? So this whole entire side is parallel to what? PQ. Good. Okay. All right. Now we're going to try to figure out what is the same as PQ. So this line here. And yeah, MR and OR, right? Because if this is half of this whole side, right? Half of that is on here, half of it goes here. Agree? So we're just, whatever it is, we look to the side that's parallel, cut it in half. That's the easiest way to do it. Okay? Good, Serenity. So MR and OR. Okay, so somebody else tell me if we're looking at NQ, what other sides are parallel, or sorry, congruent to NQ?
OQ?
Yep, so NQ, that means OQ is the other half, okay? And then look at the line parallel to it. What's parallel to NO? PR. Does everybody see where we're getting those? Okay. All right, last one, we're looking at PM. So PM is located here. Somebody that hasn't answered yet, tell me what else is parallel to PM. Remember the easiest ways to complete that segment. NP, good. So NP is my first one, and then what's parallel to this whole line? QR. So QR and NP. Again, I know sometimes when it gives you a triangle inside, it gets a little confusing, so you just kind of have to block off the stuff you don't need. Okay? All right, last one. This one's a tough one. All right, in triangle JKL, show that the midsegment MN, so we want to show that this line here is parallel to JL. And show that MN is half of JL. So there's two things we need to do. First, we need to show that they're parallel. How can I show that two lines are parallel? But how do I know for a fact that those two lines would be parallel?
You find how long it is?
Oh, come on, we did this last semester. Say it again. Slope, right? Okay, so first, I want to find the slope of MN, and then I want to find the slope of JL. Now, I can do this really easily. How can I find the slope of MN?
Up 1 over 4.
I mean, I would really go down 1. We should always start at the left. So down 1 over 4, what slope is that?
Negative 1.
Negative 1/4. So slope of MM come on, negative 1/4. Okay, JL, I go down 2, right 8. What would negative 2 over 8 simplify to? Negative 1/4. So what have I just proven about these two things? They are parallel. I'm going to put negative 2/8 equals. Okay? So since the two lines have the same slope, yes, they are parallel. Okay? So let's write MN is parallel to JL. So that's the first thing it asks us to say. Then it wants us to say that prove or show, doesn't really say prove, but show that MN is half of JL.
Distance formula.
Yep. What's the distance formula? Yep. Square root of what?
It's y2 minus y1 squared.
You're close.
Oh, x squared plus y2.
Good. So it is going to take us a little bit of work, okay? But we can do it. So let's first let's do the length of MN. Now, what I might do is the ordered pairs for M and N listed up here. No. So I would probably go write those first. So N is at 0, 2. What's M located at?
Negative 4.
Negative 4, 3. That way we just have those points to kind of reference when we start plugging in. Okay, doesn't matter which one you start with. I'm going to start with 0 and subtract negative 4. So 0 minus negative 4 squared. Then I'm going to do the same thing with my y values. So I'm going to do 2 minus 3. Okay, what is 0 minus negative 4?
Negative 4.
Positive 4, yes. So I get positive 4 squared plus, what's 2 minus 3? Negative 1 squared. Okay, 4 squared is 16. Negative 1 squared is 1. So we get square root 17. Somebody take that square root for me. Just round to the 10th.
4.1.
So about 4.1. Okay? So halfway there. Now we just have to do the same thing for JL. What's up?
Since we know it, so we're not just double 4.1. That might be.
Yes, but it wants you to show that they are.
So the length of MN is 4.1.
Yes.
That's what I was saying, but you have to show it.
Yeah, but it wants you to show it. So that's why we're going to do it. You're not wrong. Since we have proved that, you can. But it just wants you to show that they're the same. Okay. All right. So we're going to do the same thing. x1, 2 minus negative 6. Square it. y1 is negative 1 minus 1. Everybody okay with where I got those numbers? Okay. What is 2 minus negative 6 or 2 plus 6?
8.
So we get 8 squared plus negative 2 squared. What is 8 squared?
64.
Plus 4. So we get the square root of 68. Somebody square root 68 for me. About 8.2. Okay. So we did just prove that MN was half of JL. Okay. Any questions on that?